Hi, so I'm going to continue with the transcendental functions now, exercises on them. Let me see here. So, integral of 2 divided by x dx equals, well, this 2 is multiplying, we can just get it out. Okay, we can get it out of the way, like 2 integral of 1 divided by x dx, and this is going to be 2 ln of x. Of course, you have to do the plus c, but I'm just going to skip the plus c for now. So the integral, that's another exercise, 1 divided by 4x minus 1, right, dx. This is going to be, well, this is being elevated to 1, right? So it's just like 1 divided by x, but instead of being x, it's 4x minus 1. So you can do ln of 4x minus 1. And now you got to divide by the derivative of the inner function or inner equation. So divided by, what's the derivative of this? 4. So you divide it by 4. Why, guys? Because you see, let's differentiate this thing, okay? So differentiating this, I'm going to put a d here. It's going to be 1/4 times the derivative of this. And the derivative of this is 1 divided by 4x minus 1 times the derivative of the inner function, which is 4. So this 4 is going to cancel with this one, okay? And you have 1 divided by 4x minus 1, which is what we had here. So when you're differentiating, you're multiplying by the derivatives of the inner functions. When you're integrating, you're dividing by the derivatives of the inner functions. So that's why we do this, okay? This is the answer. Here's another one. The integral of x divided by x squared plus 1. Okay. Now, what is the, this is going to be like, okay, ln of x squared plus 1 divided by the derivative. The derivative is 2x, okay? So you have to divide this by 2x, so you have to have an x in here. So you got to have that x in there, because if you didn't, you couldn't just leave it like this. You have to have this x in here so you can simplify these two, and it's just going to be ln of x squared plus 1 divided by 2. Okay, why do you have to have this x in here? Well, let's just work on that substitution thing again. All right, so let's say that u equals x squared plus 1. That means that du dx, right, equals 2x. The dx is supposed to be here, but I'm just gonna already pass it to the other side in here, and then this thing I'm gonna put it down there. So you divide it by 2x, and I'm just gonna erase this one here. Okay, gotta put a dx in here. Okay. So, and what is x? Okay, x is gonna be, well, x squared. Yeah, we can do that. X is gonna be u minus 1, and then I have a plus or minus in here. I don't know if we're gonna need it. I don't think we're going to need it. Well, yeah, okay. I'm going to leave x squared equals u minus 1. So we're just going to use these three here, okay? These three identities. All right, so let's just substitute this thing here. Now, what is, you see, because you got an x in here, right? So you got to worry about that. Okay, but let's just copy this thing here. So we're going to have the integral of x, and then you have dx. What is dx? It's du divided by 2x. So I'm just going to put du divided by 2x. I'm going to put it a little bit further away. Okay, what is x squared plus 1? X squared plus 1 is u, so we're going to put a u here. All right, so what do you have? You're going to simplify this one with this one, and now you don't have the x anymore. Okay, so what do you have? You just have the integral of du, or you can say 1 divided by 2u du. Now this 2, this is just half, so we can get this thing out of here and put it out here, and now you just have the integral of u du, 1 divided by u with respect to u. So what you have is the ln of u, right, divided by 2. And what is the ln of u? What is u? It's x squared plus 1. So we have the ln of x squared plus 1 divided by 2. And look at this. What we have here is what we have here. It's the same thing. Okay? All right. Okay. Now, 3x squared plus 1 divided by x cubed plus x dx. All right. This seems complicated, but you got to see that this thing here is the derivative of this. All right. So if this is u, that thing over here is just going to be du. And what you have is the integral of du over u, okay? Or 1 divided by u du, it's the same thing. So all you got to do actually is just say, look, this equals 3x squared plus 1 times, right, the ln of x cubed plus x, all right, divided by the derivative of this, which is what? 3x squared plus 1. Well, this one's going to simplify with that, and all you have is this. So you got to learn how to recognize these things. For example, to see if the numerator is the derivative of the denominator. If it is, you're gold. You don't have to do anything. Like in here, okay? This is of x, this is of x. So you have the secant squared of x divided, the integral, right, of the secant squared of x divided by the tangent of x. Well, the secant squared of x is the derivative of the tangent of x. So this equals ln. And now here, this is something that, look, tangent of x, right? Yeah, kinda, because the tangent of x can be negative, but you cannot have a natural logarithm of something that is negative. Okay, so you gotta put the absolute value in there. And you gotta put the absolute value in here too, right? I forgot about that because this can be negative. The integral of 1 divided by 3x plus 2 dx. It's the same thing. This is going to be ln of the absolute value of 3x plus 2, right? Divided by the derivative of this. What is the derivative of this? It's 3. So divided by 3, okay? Since it's not a 3x, you don't have to have an x here to simplify. When the derivative is just a constant, according to the variable of integration, you can just divide it by that constant, and it's fine. It's like this. Now this one's going to be longer. Here you have the integral of x squared plus x plus 1 divided by x squared plus 1, right? Now the first thing that dx. First thing you got to do in here, I'm going to do it on the side, maybe here, yeah. Well, whatever. I'm going to make the long division. Okay, so you have x squared plus x plus 1, x squared plus 1. Well, okay. So you see, this is already being kind of complicated because you can't do anything here. For example, you can put a 1, right? You can put a 1 in here, because if you put an x, guys, it's going to be x cubed. Do you have an x cubed in here? No, you can't put an x. So this is going to be 1, okay? So you got 1 x squared coming over here. You have minus x squared, so this is a 0, okay? Because this is what you do, minus x squared, 0. 1 times 1, that's 1. But coming over here, it comes as a minus 1. So this one, plus 1 minus 1, 0. And what do you have left? You just have an x, okay? Now, can you do anything? I mean, even if you multiply by 1, you're going to have x squared, and you don't have an x squared here, so that's it. So what is this divided by that? This divided by this equals the integral of 1 plus x divided by x squared plus 1. Okay, you get the remainder and you divide it by the, I think it's the divisor. Okay, this is probably the dividing or something. This is the divisor. This is the quotient. This is the remainder. So you get the remainder divided by the divisor. And you get this. So this thing equals that, right? And dx. So it's going to be the integral of everything, okay? I'm not going to put it in parentheses. When you have a dx in here and you got an integration operand here, that means that everything in between is being integrated. So you have that, which equals x, right? This one becomes an x. And here you have the thing again, plus the ln of the absolute value of x squared. Well, you see, x squared plus 1 is always going to be positive, so you don't have to worry about it, the absolute value, because anything negative squared becomes positive. So ln, right, we're considering real numbers here. X has to be different from I, because x squared equals I squared equals minus 1, okay? So we're not considering these, we're just considering the real numbers. So ln of x squared plus 1 divided by 2x, but you already have an x in here, so you're going to simplify the x with the other x, and you just have a 2 here. Okay. Now you have the integral of 2x divided by x plus 1 squared. You gotta watch out for this thing here, for this power, because it's a 2, it's not a 1, okay? The integral of 1 divided by x is x to the 1, so this equals ln of x, right? And you gotta put the absolute value. But if it's the integral of 1 divided by x squared, well, this is the integral of x to the minus 2, which is just gonna be minus 1 divided by x, okay? This is the integral, so minus 2 plus 1 minus 1. Divided by the minus 1, everything becomes minus 1 divided by x. So you're going to use the ln when the power here is 1, but the power here is not 1, it's 2. So we should use substitution. So u is going to be equal to x plus 1, x therefore equals u minus 1, and du equals dx. Okay, so this, I'm going to put the dx in here. This is 2 u minus 2, right? Because it's 2 times x. 2 times u minus 1, so it's 2u minus 2. dx, which is du. And this is being divided by u squared. Okay. Well, you can separate, well, yeah, it's the integral. You can separate this thing. You can say that this is going to be the integral. I'm getting the 2 out. Yeah, I'm getting the 2 out. I'm going to separate the fractions. I'm going to say 2. I'm just worrying about this part. Okay, so I'm going to get the 2 out. And then you have u divided by u squared is just 1 divided by u. du. And now you got a minus and a 2, okay, of the integral of 1 divided by u squared du. So this is going to be equal to, well, this is going to be 2 ln of u, right? 2 ln of u. Now you have a minus, but here's the thing, like minus 2, right? Times the integral. Well, this is going to be the same thing. U to the minus 2, integrating that's going to be u to the minus 1 divided by minus 1. So this is going to be minus u to the minus 1. So, but we already have a minus here, so this minus becomes a plus, right? And u to the minus 1, well, I'm just going to put it 2 over u. And that's it. And now we back substitute. So it's going to be 2 ln of u, so it's going to be 2 ln, what's u? X plus 1. Okay? Yeah, this is a little bit, I'm going to put a real one here, like this, because otherwise it's going to confuse with this absolute value operator. So you have the 2 ln of x plus 1 plus 2 divided by x plus 1. All right? And of course you have to have a c, but never mind. There's something else too, guys. You see, you got a c here, which you call c1, and plus c2 in here. So if you're really considering the c's, you can just add all these things together and you can just say this is this plus c3. And what is c3? Equals c1 plus c2. When you guys are studying differential equations after calculus, you're gonna have to make use of this stuff. But this is not for a long time. Now here's an interesting one. The integral of 1 divided by x ln of x. Of course, this x has to be positive, okay? Okay, dx. And then you go like, whoa, this is kind of complicated, but not really. You see, what do we have here? This is the integral of 1 over x times 1 divided by ln of x, okay? dx. So here's the thing. If you were going to replace this, if you're going to say that u equals ln of x, what is du? It's 1 divided by x. So you can say that this is du, right? And something else too here, guys. Let me just see how I'm going to organize. This is du dx. So the dx comes over here, multiplying. So this is going to be a dx here. And this x comes over here. Okay. So you have that, right? So look. This is going to be the integral of 1 divided by x. I'm not going to replace this x here now. Okay? 1 divided by x times 1 divided by u. And look at that. What is dx? Because we got a dx in here, we have a dx in here. It's x du. So x times, right, times x du. Well, this x is going to simplify with this one. And what do you have? You have the integral of 1 over u du. This is going to be ln of u, right? But what is u? u is ln of x, so this is ln of x. That's fun. Of course, you don't have to replace all these things. All you gotta do is understand let's do it straight. Well, I'm not gonna rewrite this. All you gotta do is see the pattern, okay? It's 1 divided by ln of x. So this ln of x in here is elevated to 1. So whenever you have something in the denominator which is elevated to 1, all you gotta do is ln of whatever is in the denominator, right? Which is what? ln of x. So it's ln of x. Great. Divided by the derivative of the denominator. What is the derivative of ln of x? Is 1 divided by x. But you have 1 divided by x here. So it's 1 divided by x divided by 1 divided by x, which is 1. It makes this 1 divided by x disappear. So just by looking at this, I already know that it's this. Okay? And of course, the correct way of writing this is actually whenever you have ln, is ln of the absolute value of ln of the absolute value of x, okay, because you can't have ln of something negative, and there you go, plus the c. As you get more comfortable with mathematics, you start forgetting all these. I mean, it becomes second nature, so you don't really care about all these details, you know, you just do things fast. Find the integral of the tangent of x dx. Now, we knew what it was before, okay, at least I know. The integral of the tangent is minus ln of the cosine of x, okay? But let's try to find this out. This equals the integral of the sine, and it's the sine of x, so I'm just going to write s, okay, it's the sine divided by the cosine, right, dx, okay. So you have the cosine here, which is elevated to 1, so we do that u equals the cosine, and if u equals the cosine, then du dx equals the minus sine. Oh man, it's the minus sine, right? This dx is dividing here, so you pass it over here as a dx, and you put the minus s in here. So divide by minus s, right? Okay, and you delete this from here. Okay, and there's something else too. Yeah, okay, we got it. So you see, the derivative of cosine is the minus sign, but you have a sign in here, so you don't have to worry about it. So we do this. This is equals the integral of the sine divided by u. What is dx? Minus du over s. I'm going to take the minus out. I'm going to put it in here. And then you have du over s. You simplify this one, okay? This is minus the integral of du over u, which equals minus ln of u, okay? And what is u? U is the cosine, so minus ln of the cosine of x plus c. But again, if you recognize the pattern, if you see that the numerator is the derivative of the denominator, then you're fine. All you got to do is ln of c, right? ln of the cosine divided by the derivative of the cosine, which is what? Minus sine. Dividing with this minus sign in here, you got this, minus ln of the cosine. I know that I keep repeating things, guys, but it's the best way to fix something in your mind, is to keep repeating the same thing over and over again. However, sometimes it's complicated. The secant of x dx. Now, what is the secant? Secant equals 1 divided by the cosine. Can you do this? Ln of the cosine divided by the derivative of the cosine, which is minus sine. Can you do that? No, you can't. okay? Because it's just not going to work. You would have to have a sign in here, but you don't. So those guys came up with something clever in here. What did they do? They multiplied the secant, okay, times this secant plus tangent divided by secant plus tangent. Because then what you're just multiplying it by 1, you're not changing anything. Well, this is going to be the secant squared plus secant tangent divided by the secant plus the tangent. Well, guess what? If this is u, this is du, okay? What do you have in here? You have, well, yeah, this is going to be multiplying by this stuff, guys. You have this stuff, okay, in here. So you have du divided by u. So all you got to do is ln of u, and things are just going to work out. So this equals the integral, well, let me undo this in here. Yeah, equals the integral of this. Gonna move it over. Okay, when you multiply, you get that. And this is just gonna be the ln of secant plus the tangent divided by the derivative of the secant and the tangent, which is this. So it's gonna simplify, okay? This thing here is going to be copied down there, and we're going to simplify, so it just works. That's it. That's the answer. ln of secant plus tangent. Here's another one. The integral of the square root of 1 plus tangent squared dx. Well, there's an identity that says that 1 plus the tangent squared equals the secant squared. So the square root of the secant squared equals the integral of the secant. And we just found out what that is. The integral of the secant is ln of secant plus the tangent. Okay. Now, of course, the plus c, don't worry about it. Well, here's something interesting, kinda. I just wanna, doesn't have too much to do with what we're doing here now, but it's something that I'm gonna have to start talking about new topics, because otherwise you guys are not gonna pick this up by the time it's needed. Okay. So it's the integral of the tangent, okay, from 0 to pi divided by 4 dx. Of course, this is of x. I'm going to put a small x in there, okay? Now, we found out that this equals the minus ln of the cosine of x, absolute value, and all this is coming here from 0 to pi divided by 4. All right. Now, when you substitute this, so this is going to be minus ln of what? What is the cosine of pi divided by 4? It's square root of 2 divided by 2. Right? Now you got a minus and a minus, so you have a plus. The cosine of 0, which is 1. Okay. Yeah, okay, fine. You got that. Now, what the exercise is actually asking for, okay, is the average value of this. So get this, when you have the tangent of x, you're going to have a graph in there. I'm just going to sketch the graph in here now. The graph, I'm going to show you the graph later, but for now I'm just going to sketch. It's kind of like this, okay, kind of like that. This is 0, this is pi divided by 4, so you have in here, right? Okay, and you care about this thing in here. But what it's asking for is the average value. So this is the value, okay? Just do this in your calculator. Just do 1 minus ln square root of 2 divided by 2, and you're going to get a value in there, which is the value of the entire area, right? But guess what? It's asking for the average value of this thing. This is a scalar, okay? Just make sure you guys understand. This is going to be some kind of number. So it's asking for the average value. So what do you have to do? You have to get the number and you have to divide by this entire space in here, okay? Which is pi minus 4, pi divided by 4 minus 0, pi divided by 4. But if you're dividing by pi divided by 4, it's a fraction division. You keep the first one as it is and you multiply by the reciprocal of the second one. So you multiply this by 4 divided by pi, all right? When you do that, you're going to get an approximate value of 0.441. What does this mean? Okay, so this is a scalar, and when you multiply by 4 divided by pi, you get 0.441. It seems that it's a point kind of around here. It's this distance, okay? It's this distance right here, right here, right here. I'm showing it 3 times because it's so small. Okay, so what does that mean graphically? Because just this thing right here, just the scalar, is this whole thing, okay? It's the value underneath the area, right? Because that's what the integral is. It's the value of the area underneath the graph. Fine. It means that if you got a, how can I say, a horizontal line through here, because I didn't do this horizontal, so I'm just gonna here, then you have this, oh man, you have, let's see if I can do this correctly now, this here, and you have that, okay, and here's the graph, kind of like that, okay, and the point is around here. So if you get a horizontal line that cuts right through it, okay, I'm gonna move it a little bit up, there you go. What does it mean? It means that this area right here, this entire area right here, is gonna be equal to this area, okay? Because it's the average. You're getting this entire area and you're dividing it equally among the entire domain. You're dividing it equally, you're spreading it across the entire domain. So if you're spreading it equally across the entire domain, it's not going to be low here and a little bit higher here and a little bit higher. No, you're spreading it equally. It's like water. So you have the same height all over, okay? So this area here equals this area here. That's what it means. And later in this course, we're going to have to know this, what the average means graphically. So that's why I'm showing this to you. Okay, I think this video has already been long enough. The next one is inverse function. So I'm going to leave it to the next video. And I'll see you guys there. Bye.